Smile, you're on mute.
Okay. Hi everyone, welcome to the 6th edition of Serverless Saturday. Today we are again back with one amazing Saturday full of learnings. We have lined up with amazing speakers for today. Srishit, would you like to tell everybody about them?
Yes. First of all, a very warm welcome to everybody joining us today. So this is Serverless Saturdays, an initiative from AWS User Group Tirupati and the Serverless Group from Bangalore. We hope you have a very informative weekend this time. We have some interesting sessions lined up. And as always, uh, we hope that you get enough knowledge and you'll have a good weekend ahead. So before we proceed further, as always, we have a few announcements. The first one is about the AWS Community Day South Asia. So this is a community day that is being organized by various AWS user groups here in India in collaboration with the user groups from Sri Lanka, Nepal, Bangladesh as well. So the CFPs for this event is open right now, and request all of you guys, whoever is interested in sharing your knowledge, sharing your real life experiences, please go ahead and submit the CFPs. We will be sharing the link in the chat section here. So that is the first announcement, and do register as well for the community day. Given that everything is virtual, so we don't have any geographical boundaries right now. So anybody and everybody across the globe can just go ahead and share your submissions, and hoping to see a few of our audience there at the AWS Community Day. Yes. Smile, could you go for this one?
Yes. So if anybody is looking to prepare for AWS certifications, so we have an offer. There are you will get a free practice exam for all the associate exams if you are preparing for.
So if you guys are preparing for the AWS certification, certainly please do take a look at this page. Again, we will be sharing the link in the chat section. Yes, and another important announcement is the AWS Community Builders Program. This is an amazing program and initiative from the AWS where you get a chance to be a part of the amazing community of community builders across the globe, and you get some really cool privileges like you get some webinars and hands-on sessions, and of course you'll have mentors across the globe, like-minded mentors and people across the globe that can you can interact with, and we will be posting the link for submitting the application as well here in the chat section so that you guys can go ahead and apply. The last date is on August 30th, so we are close to the end. So please do take a look at it. It's a really amazing program. I, in fact, was a part of this program before I became a serverless hero, and I can vouch for it to be one of the a very vibrant community with some amazing folks across the globe. Coming to today's session, we have two amazing speakers today. One is first we'll start with Paweł, who is from EPAM Systems, and he will be walking us through about how to deploy Lambdas with CodePipeline. And yes, so Paweł, I'm adding you to the screen.
Yeah.
Hi, Paweł, how are you doing?
Hi, thank you. Good. Still, it's morning here in Poland, but I'm happy to be here with you, and I hope this session will be interesting.
Thank you so much, Paweł, for joining so early from Poland. I'm sure our audience will be really excited to have you here and listen your experiences. So over to you, Paweł. So please start with introducing yourself.
Right. So my name is Paweł Piwosz, as you said already. I worked and I live in Poland, in Krakow. For 2 years right now, 2.5 almost. I'm working for EPAM System. EPAM Systems, and I have overall more than 20 years of experience, I think. So I saw enough things in my life which I don't want to see again, but I'm sure I will see it again. Right. So that's about me, and let's get started then, I think. So yeah. My name is Paweł. I'm working for EPAM Systems. I'm proud to be DevOps Institute ambassador and also participating in this program mentioned earlier, AWS Community Builders, as it's a great place and great place to grow, to find new materials, new people to share knowledge with. So it's really amazing place. And if you wish, you can send your application. To prove that I know what I'm talking about, I am certified DevOps Pro engineer from AWS. So I think it means that I know what I'm talking about. I hope, at least. So let's get started about discussion about CI/CD, right? So as I'm doing a lot of technical interviews, I know that we need to define on the beginning the topic on which we will move ourselves today. So first of all, if you have Jenkins in your stack, it doesn't mean you have proper CI/CD. It means just that you have Jenkins, nothing else, right? So this is only the tool, nothing more. It's helpful tool, powerful tool, but only the tool. So CI/CD is definitely something what is bigger than just the tool set we are using in our work. So first, let's demystify what CI/CD is, because there are a lot of abbreviations like CI, like CD, like another CD, and sometimes we have problems to understand what is behind that, right? So first, I want to go through elements of CI/CD and explain them very shortly. So first of all, CI/CD has, generally speaking, two elements, but in two different flavors, let's say. First is continuous integration, continuous delivery, and if we are automated enough, let's say this way, we can talk about continuous deployment. So what is continuous integration? This is like a regular commits to the version control. It contains unit test, it contains artifact building process, it contains everything what is related to this part, right? Continuous delivery contains things like automated testing, like automated delivery of artifacts, but to all environments except production, right? I mean, automated way. We are controlling what is delivered, and I'm calling this like a one-click deployment. It means that on the end of the process, just before we deploy stuff on production, we need to acknowledge, we need to click some button, yes, deploy, right? That's it. This is continuous delivery. And continuous deployment is automated installation of artifacts on production system. So this is like a zero-click deployment. There is no intervention from the user. Everything is automated from the code to the production. So let's maybe make it more visible, right? So how we can describe CI? So CI starts with the commits, right? With the version control, with code somewhere in the Git, GitLab, GitHub, etc., repository, right? Then we have static code analysis. For example, SonarQube. Right? We are analyzing the code, no matter if this is on the pull request level or on each commit, it doesn't matter here. After that, we can have some unit tests if needed. We are building the artifact. We are testing this artifact, and we store this artifact somewhere. And this is the place where CI ends. So CI starts with the, let's say, with commit, and ends in the moment where we have our block, our artifact, It can be executable, it can be tarball file, it can be anything like that. And we are pushing it somewhere to Artifactory, to S3, whatever. We are storing it somewhere. And CD starts in this place. We are collecting this artifact. We are deploying it to some first environment, for example, QA. Then we are doing tests, deploying it to release candidate, doing tests. We have manual approval, and then deployment on production, right? And this is continuous delivery. If we remove this step, we are start to talk about continuous deployment. So CI/CD, we can say that's kind of simple process, right? We have Jenkins, we have our pipeline defined, and everything is fine. But honestly speaking, what is behind CI/CD is very important. If we are talking about DevOps, where CI/CD is kind of backbone, we need to understand definitely more than just the groovy language to write our pipeline. So how to define CI/CD? We can extract or identify a lot of elements here. For example, we can start with constraints. And good example here to talk about constraints is, for example, AWS Code Pipeline, right? Because our constraint here can be version control system, which we are using. If we want to combine Code Pipeline with Bitbucket installed on-prem, yes, we can, but we need to do a lot of custom wiring to make it work good enough, let's say. Another constraints can be related to the security and the organizational design of the company for which we are creating the CI/CD. For example, if we can use cloud environments for it, if you can use a very specific toolset for it, etc., 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 etc. Second element can be branching strategy. Right? This is very important. If we are going with trunk, if we are going with Git flow or any other approach, this is like base of selecting everything. SDLC, of course. Responsibilities. We need to define roles. Who is responsible for what here? Of course, deployment strategy, right? So we started with branching strategy. We're finishing with some kind of deployment strategy. If this will be Canary, if this will be blue-green, if this will be rolling updates, etc., etc., etc. Everything here is very important when we start to design approach to CI/CD, and it's quite obvious, I would say, that this should be like a global approach to stuff. So we are not talking that one repository is done in this way, second repository is done in another way, and the third in completely different way, right? So we should have some kind of consistency here. Another some things, like for example, how we will version our artifacts for prepare them for deployment, how we will do our releases. If this is like a scheduled releases or ongoing releases, if this is a continuous deployment, if this is continuous delivery, or there is nothing like continuous at all. What kind of toolset we will use, how we will approach to rollbacks, very important. Very often omit point, right? Or missed point during our divagation, what we want to do from our CI/CD. If we use infrastructure as code there, how we will work with infrastructure as code in our CI/CD processes. What kind of quality gates we have, right? And finally, how we will monitor it. What metrics, what measurements we will take from our CI/CD, and on what we will base in order to say, okay, our CI/CD works perfectly fine. Right? So it's complicated enough. Right? So we will do today something simple, very simple, really, but we will complicate it as always DevOps do, because why not? So together we will build that kind of application. Right? We will have Lambda function, very simple Lambda function, located behind API gateway, and users can just go through this API gateway and trigger our Lambda function to get some results. So we will create the whole pipeline using AWS Code Pipeline here. Code already is stored in code commit. Of course, you can create code commit repository automatically using infrastructure as a code approach, but in this specific case, we have already the repository created and code is there. Deployment will use Cloudformation, and really both deployments. So I mean, the code pipeline itself will be deployed using Cloudformation, and then deployment of Lambda function will use SAM model, so serverless application model, which in fact is extension for Cloudformation, right? So we will use Cloudformation twice today. So yes, this is exactly what I said. So first, small introduction, what elements we will use if you are not fully familiar with them. So AWS Lambda, right? So what it is, Lambda is a compute service, AWS compute service. Runs code without provisioning on managed servers. That's why we are talking about serverless, because there is always some server behind, right? It's scalable automatically. So this is the beauty of AWS Lambda. Is this pay-as-you-go model? So you are paying only for what you are using. That's perfect. And supports many languages here. Not only languages, but also custom runtimes. So if you wish to have Bash in Lambda function, yes, you can. I'm not saying this is very smart, but yes, you can. And AWS has great monitoring capability here, monitoring observability capability. So we have CloudWatch, we have X-Ray, we have Lambda Insights, which is quite new. It has like 1 year, I think, or almost 1 year. But Lambda has one very important issue which we need to emphasize here. This is cold start, right? And when you build your application, when this application must be interactive, it is a website, whatever, this kind of issue may be very critical for you. So we can see very clearly this cold start problem with X-Ray and Lambda Insights. With Lambda Insights, we can even see how many invocations of our function is suffering from this. In X-Ray, of course, you can have the same information. And what it is, so cold start is this initialization process before your actual code will be executed, right? So in languages like .NET, like Java, this cold start is quite huge. With .NET right now is definitely better. So starting with .NET 3.1, we were able to make this cold start almost reasonable, let's say. So it is really small, but it exists, right? With languages like Python, Node.js, this cold start time is slower, but it is here. You will see it on the presentation. So when your Lambda function is warm, prepared already, and you invoke it once again, there is no cold start, your code is executed, let's say, immediately, and everything is fine. But you need to be aware of this cold start here, because this can take more even than execution of the function itself. And this is quite critical in some applications. We will use serverless application model here to deploy our Lambda and deploy our API gateway to AWS. So what it is, it's a way of programmatically create, manage, and deploy Lambda functions. Well, so this is open source framework. It's extension for CloudFormation. So generally speaking, when you execute your SAM model, you are creating CloudFormation stack. It's optimized for serverless, obviously. It organizes related components and resources. So you have Lambda function, another Lambda function, layers inside Lambda functions if you need, and things like API gateway behind. You can create it in one template of SAM model. and we are able to locally debug and test our code. We will not do it this thing today, anyway. So CloudFormation, right? I said about CloudFormation multiple times. Yes, obviously you can do everything like this with Terraform, which is quite popular. I would say even more popular, but somehow I stick with CloudFormation for many years, and I prefer this because I understand it better. So CloudFormation is a infrastructure as a code tool, and infrastructure as a code is a tool which helps you to propagate all errors and misconfigurations from your templates to all environments automatically. It doesn't sound good, right? So let's make this definition a little bit better. So infrastructure as a code is an automated way to create, update, and manage your infrastructure as quick as possible, really, but it's not just about the speed. It's about the storing templates, it's about the versioning templates, it's about the possibility to move your infrastructure from place to place very easily, etc., etc., etc. We will use here very cool functionality of CloudFormation. It is called change sets. So yes, you can create and update your stack just directly, so by saying update stack, etc., etc. But definitely preferable way is to do change set, because you can differentiate the way how you interact with this change, with this update. So we have create change set on the beginning, and this can be treated as a kind of change log between existing stack and template prepared for deployments. We can use this as a approval step, so we will do exactly this. And also based on this, you can create a change log for your version control. So it's quite self documented tool. And then we are executing the change set, where we apply the changes to existing stack. That's simple like that. In case of error, we are reverting the changes and bring back the previous version of the stack. Last element here, which we will touch in order to deploy our Lambda function, is obviously AWS Code Pipeline. And AWS Code Pipeline has a couple of tools inside. So we already talked about code commit, where our code is stored. It's like a Git repository version control system, where you can store and interact with your code. We have code artifact solution, on which I waited very long time, and it's quite powerful. So you can store your artifacts there, starting with npm packages, pip packages, .NET packages, Java, etc., etc., etc. Very nice tool. We have code build, which is an essence of code pipeline. So we can use code build to build our artifacts, to test our artifacts, to do everything what we need to do with our artifacts. Sometimes in some environments we are using also code build also for deployments, but especially for deployments, we have another component which is called deploy, which works great on one account or multi accounts. Has a lot of possibilities, a lot of functionalities related to proper deployment strategies. So it's a quite powerful tool. Of course, we have CodePipeline, which is kind of wrapper for everything what I said here on the list of the components. And another tool, a very nice one, is CodeGuru. It's not the part of CodePipeline itself, it's the separated service, but it helps you to understand and see potential problems, issue with your code, right? So this is like a profiler, this is like a reviewer. Today we will use the reviewer only, but very powerful, very helpful, based on machine learning processes. So I encourage you at least to test it, right, to see what we can have there. So do you remember what we will deploy, right? So we will deploy a very small Lambda function with API gateway. And for this, we will use a couple of elements. So to work with this simple thing, we will use obviously AWS Lambda. We will use API gateway. We will use pipeline CloudFormation and SAM model CloudFormation. We will use chain sets, event bridge in order to do two things really, because CodePipeline itself doesn't have, or code build itself doesn't have this direct integration with code commit. We need to have some event which will trigger our pipeline. We will use event bridge here to in order to have it, and also because we are building code and we are building continuous delivery process, we will have notification that our change is ready to be deployed, right? We will of course use code commit, code build, and code deploy. We will use simple notification service SNS in order to notify us that we need to approve something. We will use obviously IAM roles, policies, etc., etc., and finally we will use S3 bucket in order to store our artifact and collect our artifact later. So quite a few services for a simple thing, right? So that's what DevOps is about, to complicate easy things. So if you have enough of icons, I'm sorry, because we will have more. This is what we will build. This is our code pipeline, right? So on the beginning, we have our code pipeline here and CloudFormation, which will create this code pipeline. Inside code pipeline, we have code commit, which at this moment is created, and we will not use it to in our scripts. We have code build for testing. We have code build for building artifact, and we have code deploy, which will use our notification, simple notification service to inform us that we need to approve something. And as I said, here we have the event, which will somehow integrate code commit with first code build of the process, right? And this all stuff will use SAM template in order to deploy API gateway a Lambda function, right? This is quite simple. Here in code deploy, we will have like 3 steps. And then this is quite nice thing about code deploy and chain set, CloudFormation chain set, which I showed you before. So this is what we will do. First process here will be create the chain set. Then we will send notification through SNS, in this case to me, in order to say, hey, you have change waiting for you to be approved. And then if the change will be approved, we will execute the chain set, right? So enough talking. Let's go to our AWS and see what we have there. At this moment, what I need to do is to log in there. Give me a second, I will do it. I'm the only one person which I know who has a federation and organization, AWS organization at home. So I need to log in there. Click here, give me a second. I will show the screen very soon. Of course, today my internet is slower than usual. Why not? All right. So we are almost there. Right. First thing, what I want to show you that in CodePipeline we have nothing. Yes, exactly. It's empty, right? So let's jump to CloudFormation and see that we have nothing there as well. It's quite slow for me today. All right, so we have empty stacks. empty stack leaks. And as you can see, I'm using EU Central 1 in Frankfurt because this is the closest location for me to me. So I use this one. Let's take a look on the code first. So this is how I design my repository here. I have a few directories, which is interesting for us. It's Lambda function where my code is stored. The function is really simple. The most important element here, of course, is to define this it like we should for Lambda function, and I have the few functions here on which I'm doing the unit tests. So I'm adding the two numbers, multiplying them. Very simple, very simple, right? So here I even have the the variable already set for it. And this is it. This is very simple. As I said, very simple function without any deep logic behind. For tests, I have very simple test here as well. I multiply them in order to have like very nice report. So I'm just adding the numbers and that's it, directly to the function, and I'm doing this cycle 4 times in order to have more tests on the end. Here is our SAM template, right? So I'm saying this transform to AWS serverless. This is needed for SAM model to say, or Cloudformation to say that this is a SAM model which need to be transformed in the classic Cloudformation. And I have very simple definition here. What will be the handler of my function, which need to be executed when my function is invoked, where I'm storing the code of the Lambda function in order to be deployed here. You see this Lambda function here. What runtime I'm using, Python 3.8. What is the description, memory size timeout. This is the definition for my infrastructure of Lambda function. I also enable tracing, so this is preparation for having this in X-ray, the visibility in X-ray. And here I'm creating very simple API which have only one endpoint, nothing else. So as you can see, very simple stuff. And the complicated things starts here. So we have our code pipeline definition, and we can go through it one by one. So obviously I'm using YAML. By the way, I start to use Cloudformation using JSON. I think at that time we didn't have YAML, and it was not easy days for me, let's say. I have a couple of parameters here. So what will be the notification email where I will send the notifications? This email will be automatically added to the subscription. I need to manually confirm this subscription, but this part will be done automatically because I have already code commit already created, right? And I have code there. I will show you this in the moment. I need to say to my code pipeline where and into this Cloudformation where this repository is located, right? And then I'm building resources. This will be artifacts bucket where where Lambda function will store all artifacts during the code pipeline. Will store all artifacts during the building process. I'm creating the notification topic. I'm creating a couple of roles for not only for Lambda function but also for code pipeline, code deploy especially. So there is a lot of roles and policies created already. Some of them are shaped well for the use case itself. Some of them are still, like here you see, wide open, but this is not the what we have today talk about, right? Lambda deployment role. So this is for code deploy in order to be able to use CloudFormation to deploy my Lambda function. And then we have definition of, this is still another role. We have our definition of pipeline, right? So AWS code pipeline, concurrent pipeline. So this is like a wrapper for all what we have inside our code pipeline. We have stages here, informations about stages. What is the artifact source? So this is information that this is the first block. We are pulling the code from where, etc., etc. Right? Second step is test and coverage. So we are using code build in order to do that. And a little bit later, we will go to the configuration. But here we are defining our blocks only. Third block is building the artifact. So Lambda function will be packed into zip file and sent to the S3 bucket. And the fourth step is deployment. And here we have the configuration. We are using change set replace. So we are using change sets here. This is the best practice, I would say, or good practice to be used. And this deploy Lambda has 3 steps. We have create change set. We have manual approval step here, right? And we have executing change set after the manual approval is confirmed. Here we are saying what the kind of artifact store we will use in scope of our code pipeline to not repeat this step for every single block. And here we start to defining the blocks, the code, what the blocks will do. So we are starting with Lambda tests. You remember here we had actions. We are using a block called Lambda tests with configuration here, project name, right? This is our project. So now our project is here. We are defining what is inside, and the most important element is here. We are saying what image will be used by this block. In our case, it's Amazon Linux 2 version 3. What is the source? So this is sourced from the code pipeline. And what we will do here. So this is very simple, very common way of defining steps into CI/CD blocks, right? So we will install we'll use some phases. One of them is install our needed packages. We will build some stuff. Here I'm using PyTest and creating the code coverage code. So we will test 2 things really: the coverage and unit test pass rate. Right? In my case, it need to be 100% of the pass rate. And we will publish our reports in 2 different directories. Let's say Lambda test units, where we can observe the quality of our unit tests, and the second one, Lambda test coverage, where we can check the coverage of the code. So this is one block. Second block, we are building the package. So as you can see here, I'm using AWS CloudFormation to package the template file. The template file obviously is our template, right? So this one here. Here, you see, template, YAML. And that's it for the code build part. Code deploy was defined previously, right? Here you can see this event, which we'll use to connect code commit with code pipeline. So if something will be changed in our repository here on branch master, it will create the event, and the event will trigger CodePipeline to run. Here also I've created the association to CodeGuru Reviewer. Reviewer will help us in case of any pull request created to assess the code. In this case, code is very simple, so there will be nothing fancy there, but I will show you how it looks. Right, so this is it. And always where we have any kind of automation start with manual work, right? So in our case, the manual part will be to execute this Cloudformation script and to run our stack in AWS, to create the stack in AWS. So let's do that. Here I am in my directory. I'm using PowerShell, by the way. So you see everything here. So in order to create our stack, we will use obviously the AWS command. In my case, it will be Cloudformation, obviously, because this is the service which we are using, right? I need to Cloudformation. I need to pass my profile here because I'm using multiple accounts. So for this case, I created a profile where I have configuration of my access keys, etc., 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 which key is called the demo. And now I inform this Cloudformation service what I want to do. So I want to create stack, which will be called for example, Lambda pipeline, right? I need to pass information where my template is. Of course, at this moment, I have my template here in my local directory, template body, and in order to pass my local template, I need to say file, where this file is stored. So this file is stored in AIC, and it's called CodePipeline YAML, right? As we will create some roles, some stuff related to AIM, I need to say to Cloudformation that I know that some IAM intervention, some IAM interaction is needed. That's why I need to pass information about these capabilities to Cloudformation, and this capability in this specific case is capability IAM. Generally speaking, this is enough, but we need to customize a little bit our execution. You remember I showed you on the beginning of this Cloudformation template that we have some parameters, right? So right now we need to work with these parameters, and we will pass information what kind of parameters we want to set and how. So first, parameter key. In this case, it will be a notification email. I will set the value here to my my private email. And it will be, I need to use, of course, this quotation here. It will be, by the way, you can contact me on this email if you wish. And I need to set second parameter, which is our repository name, to which we want to be contacted or integrated. So again, parameter key. In our case, it is repository name, and of course, parameter value. It will be Cicd Lambda. Right. Before I execute this, I will show you the repository to be sure that we are on the same place. It will be this one. Yeah, this window. So let's go to Code Pipeline. No, I'm already there. Anyway, okay. And here in source, we have code commit and repositories. And in our repository, we have Cicd Lambda already created, and we have code here as well. The same code which I showed you minutes ago, right? So it's here. All right, so let's execute our code and let's check if I didn't do any mistake. So AWS respond to me that this stack ID, this stack with this stack ID is created. Let's see it, if AWS is right. Yeah, something is going on here. All right, so let's go inside and see what is going on. So as you can see, after the spinning wheel, yeah, so we have our Cloudformation is being created. You see it? We need to wait a little bit, and after a few minutes, maybe less, everything will be created here. Every single resource, etc., etc. We are creating them. We can see these resources here. Yeah, so we see what is created. So the stack is still in progress. So this is our event. When something is pushed to master, it creates the event on which CodePipeline is triggered. Right now, I should receive an email where will we? Give me a second. Yep. So I received an email in order which asked me to confirm my subscription. Let me show you. As you can see, yeah, here I need to I need to confirm my subscription. So let's do that. Yes, my subscription is confirmed. Perfect. What's going on with our stack? Looks like our stack is completed. Yes, create complete. And surprise, surprise, when we go to stacks, we have our stack here, which is completed, etc., etc. So everything is done here. Let's check if we have our pipeline. Yes, we have, and even more, this pipeline is already in progress. So the deployment of our Lambda function started already. That's nice, I would say. So we have this get source, pull source, and get source block, right? After that, we did the test and coverage block. Let's go inside and see what is inside. After a long time of loading, yay! So first of all, we can see what our block did, every information, right? So we have information about every executed command, etc., etc., etc. We can check the logs very easily and see what is inside. We can see our phase details, which can be useful when you build your observability for CodePipeline. and to understand how fast your process is. And the most important element here is our reporting. We have, as I said, 2 report groups here, as you can see. One is for test coverage, one is for Lambda test unit tests. So let's open both of them in separate windows and go through them. Of course, there is no trend, etc., because this is the first run, and we can see there is no trends, obviously. There is a lot of them because the name of the test is the same, and I executed this pipeline multiple times. But let's see last executed test. As you can see, we have information that 20 tests were passed successfully. Report duration is like this. Pass rate is 100%. Here we have the even the test cases, which we can even see. In this case, there is no message because this is a very simple test, but you see all of tests here. So this is about the unit test report. So how it looks for code coverage. We have like a constant 87.5%. Let's see the last one. So 56 lines is covered, 8 lines is not covered. We see everything here, all elements, all files into in our directory with the code is visible here. So very useful, very nice, very cool reporting. I really like it. In case of infrastructure as code, you can implement tools like Chekhov, like for example, Chekhov, and see very similar reporting for your infrastructure as code templates, where you can see any kind of issues, misconfigurations, etc., right? So this is the step. Let's see another one. Another step is building artifact, right? So let's see what is inside. Again, it takes some time. It's bringing me memory from late 90s, where I wait a lot of time for every page. So generally speaking, we are building the package here, running command AWS Cloudformation package, template file, template YAML. This is our template file, right? We store it in this artifact bucket. This is taken from the reference from the variable, so I don't need to add anything. This is automatically created by my Cloudformation template. And then I'm storing the template somewhere. So for phases, as you can see as well, we have upload artifacts here, which is success. There is no reports because there is no need to have any reports in this specific place. So let's go here to S3 and see how our bucket looks like inside, because this may be a little bit interesting and a little bit unexpected, let's say. Because we created the zip file, right, this package, and when we enter the it should be enough, but when we enter the S3 bucket a couple of hours later, come on, we have our bucket here. We see a lot of stuff. So this is our package which we created, but there is some specific directory where we have something more. So CodePipeline is using this specific S3 bucket in order to exchange information between the blocks, right? So one block, in order to be able to work on specific code, specific packages, need to have it somewhere, because we are not working directly on the repository. We are pulling the code and then passing this like a mid semi-artifacts between the blocks, and we can see this here. So we have Lambda build objects here, and we are working on these objects directly between the stages, between the blocks, right? So we finished CI here. CI is done. So we started to deploy our Lambda function. So we created the change set here, right? And we are waiting for our manual approval. Let's see if I have some manual approval. Looks like I have. I will show you in a second, or 2 or 5, depends on the connectivity. All right. So suddenly I'll receive this email, which is informing me about, about something. Yes, loading. Yeah, so the following approval action is waiting for me. Pipeline details, Lambda pipeline, Lambda pipeline, stage name, etc., etc. It's quite a generic message. I can go to this from here, but I will not do it. I can go here, but first, let's see our Cloudformation. As you can see, we have new stack called Lambda demo, which is in review in progress. All right, let's see. Looks like everything is fine. Let's go to change sets. And this is our new change set. Let's see what is inside. We see that change set is created. And we have information. All right, so these elements will be added to our stack. In our case, we are creating the stack, obviously. So everything is new here. So, all right, looks pretty decent. I will not execute it here. Let's come back to here to the stack itself. I will review and approve it from here. All right, approved. Right now, I'm waiting for the execution of our change set. So it will take a couple of minutes. Come on. Be faster, AWS, today for me, because my time is running out and I want to show you one more thing. Right now, in theory, my change set should be gone, yes. And my Lambda function should be in the process of being created. So let's go to Lambda functions. We still are in progress of creation. We are creating, of course, the application. We are creating the Lambda function itself, etc., etc. Right? Let's go to functions. Yes, we have our Lambda function here. So we have all information about our Lambda function, even source code. But now what I want to do is create a test event in order to be able to show you how our Lambda function works. So this is very simple. I don't need any to pass any information here. I'm saving this event and I will execute it right now. Yep. So this is the answer from my Lambda code. Remember, it was very simple one. So I did some pluses, minuses, multiplying stuff like this. So let's not waste our time here to loading the code. So it should be completed very soon. Yes, it succeeded. So our first pipeline run is succeeded. Let's do now some action with our code in order to create pull request. All right, it will be quickly. It will be quick. I hope, at least. So first of all, I will create a new branch. Yes, I am on the branch. I will update something in the function. Let's make this response something like that, very simple one, right? Everything is so slow for me today. It's Saturday morning, so everything, my computer is sleeping. Let's give very meaningful commit message. All right, and let's publish my branch to origin. Okay, so now when I go to my code commit, I should see it here. Master Serverless Saturday. Yes, I have it. I have my branch. So I showed you before that we created Code Guru connectivity. So let's create the pull request, and this reviewer which I created will work on the pull request action. So again, let's be very, very precise here what we are doing. Yeah, everything is fine. We're creating pull request. We don't have any approval rules, blah blah blah. Yes, that's true. But what we have here, we have information that our Amazon Guru review is in progress. So unfortunately, there will be nothing special in the Cloud Guru, because this is very simple, and of course you can create the problems with this simple code, but it's not the case here. So the Code Guru will analyze our change and give some meaningful recommendations. So right now, this code commit is pending. It takes some time, unfortunately. So I will not wait until this will be ended, but it will be empty because the code is very simple. What I can do now, unfortunately, I can merge the code without waiting for finishing the Code Guru part. I hope in some time AWS will fix it or change it, that I will enforce, because I didn't find this option, I will enforce merging only after Code Guru will complete and be green, right? So right now I did the merge. So when I go to code, I don't have the second branch any longer, and at this moment my pipeline should be executed again automatically because I did something on master, right? Yeah. So as we are already a little bit out of the time, it will go, it will be finished, and my Lambda function will be there. We are doing the tests. Of course, in the change set, we will see what is changed, what is new. In this case, it will be removing the one version of the Lambda function and adding another one, right? So just to finalize my speech, this is the repository of this Lambda function. You can take it and play with it if you wish. Everything there is exactly what I showed you during this presentation. What you need to do or to change Cloudformation code in order to be able to take it from, for example, from GitHub, or move it to code commit, right? So this is everything what you need to do. And very pleased to stay in touch with you if you wish. This is my LinkedIn profile and my webpage. So if you like, please add me to your list of people you are looking for, you're looking on, and I will really appreciate that. You can also find me on Twitter, but I don't have this QR code here. So yeah, thank you very much for your time. Let's see where we are here in the deployment. All right, so we are creating the change set right now. So let's see, maybe we will be able to see what is inside. Yeah, I think so. We will be. So as you can see, we are removing one version and adding another one. So this is it. This is all what our pipeline will do with the function. So yeah, give you approve, and that's done. Thank you very much for your time. Thank you very much for watching this presentation. If you have any questions, if we have time, please, I will be happy to try at least to answer.
Thank you so much, Paweł, for that really interesting session. We do have a few questions. Let me show it up.
Sure. Yeah, that is true. The serverless framework is a very nice tool to deploy Lambda function and any kind of other serverless application in other clouds as well. So here, the goal of this talk was to show you if we are able to do it with AWS completely, right? So only one thing which was not AWS was the Python code, nothing more. But honestly speaking, there are always pros and cons for frameworks, and what suits best to you, right? So the selection is what is maybe easier for you, what you already know, what you feel better complete what you really need. If this would be, for example, CloudFormation for templates, if you are working only with AWS, that's enough, right? We don't need anything else. If you have multi-cloud installation, if you have stuff like on-prem clouds, like OpenShift, like maybe even Kubernetes, etc., which you need to manage, right? Maybe Terraform is the answer here. If you have Azure only, IRM templates may be enough for you, right? On the end of the day, you can use Bash even for doing this, and then the AWS CLI, for example, if you wish. I did it multiple times because I'm me, but this is the tool, only the tool. So the selection need to be based on your needs, on your expectation. Also, who will use the tool itself. Because it's not only about you. You need to remember that sometimes you are creating some template, some base, some skeleton. You pass this skeleton to some other team. You need to be sure that this team will understand what is there, right? I had the situation where the DevOps team created something great in Python, but the developers were not very fond of Python. They prefer to have this in Golang. Hello, right? So you need to remember that. So the stack is your choice, really. There is nothing special hidden behind it.
Awesome. Okay, so we have one more question.
In different operation systems. I'm not sure if I understand, so let me attack this question from different angles. So yes, you can use everything what I showed you on basically all operating systems. So you can run the code and execute the CloudFormation from Windows, from Linux, from macOS. You can create your Lambda function based on different languages, because here we are talking about languages. We don't care what is behind, because this is serverless, right? Even operating systemless. Of course, you can create a special, let's say, special approach, because I'm not really fond of this, to have Docker on Lambdas, because this is like a wrapper on wrapper on wrapper. But you can use even Docker images in Lambda. So you can say that, okay, I want to have something on Alpine. Why not, right? You can have it. The selection is really, really huge.
Right. We have one last question.
Yes. Can we go? We do different type of deployment from our ERC from? Yes, of course you can. With code deploy, you can say that you want, for example, Blue Green. You want rolling or canary deployment. Also, SAM model itself allows you to have, for example, canary deployment. For this small example, this will be like an overhead to have something like that, and I need additional 2 hours. But you can define even the amount of how you scale or how you change your versions during the deployment process. Of course, you can add also there some test Lambda functions, which allows you to test the functionality if it works before the deployment, and how it works before deployment, and how it works after deployment. And based on this, you can do even rollbacks. So yes, you can do it quite easily. But this is another couple lines of code and another functions. And again, only one risk which I see here: if you do that something like this, and you have multiple deployments of multiple Lambda functions, right? For example, I don't know, your application contains 100 Lambda function, and each Lambda function has its own test Lambda function for canary deployment. You are already double the number of Lambda functions, right? So, and again, you have some limitations with Lambda function. You can have 1,000 concurrency executions, right? And if your application is huge and live, this might be risky. But that's the colors, the flavors around, right, which we need to play. But answering shortly, yes, you can.
Yes. Yeah, I think that's all we have. So thank you so much, Paweł, for joining us here all the way from Poland. It's so early there, and thank you so much. We all appreciate it.
Thank you very much for giving me the chance, and sorry for taking much more time than I should. That's normal with me, so you can be.
Yeah. Absolutely fine. Thank you so much, Paweł.
Thank you.
So that was our first session, and so for our next session, we have
For our next session, we have Mohammad Faiz. He's a senior data engineer with extensive interest in big data, cloud, machine learning. He's currently working at Accenture Australia, where he designs and implements large scale of cloud related data solutions for various clients, spanning interests over industries like from telco to government, etc.
Hi, Faiz. How are you doing? Faiz, you're on mute.
Sorry, I was on mute. Can you hear me now?
Yes.
2021 problem. So yeah, sorry. How are you guys? How are you doing?
We're doing good. How about you?
Yeah, I'm good. I've been listening to Pawel's session. It's been great.
Yes. So, Faiz, we are excited to have you today. And personally, it is a really interesting topic for me. I'm firstly looking forward to the session on serverless data lake. Would you please start your session by introducing yourself and share your screen?
Yeah, definitely I will. Thanks a lot, Rohit. Thanks, Mohan, too. Thanks, guys, for organizing this event. It's been a pleasure to be here today. Thank you. So I will kickstart. yeah, I'll go from here as I can. So yeah, to start off with, I'm Fayez. I will be presenting the serverless data lake on AWS. So we'll go through some of the demo today just to see how we can develop a data lake in AWS mainly. So just a little bit about myself. I'm working as a data engineering specialist at Accenture, and I'm also an AWS community builder. So yeah, feel free to connect me on LinkedIn or Twitter. We're happy to be in touch. And if you have any questions after the session, feel free to shoot me there. So yeah, without wasting too much time, let's get started. So what we have today is the serverless data lake, which we already said many times. So I don't have too many slides to go through. So just a little bit of cleanup just to set an expectation of what we'll be going through today. We'll have some introduction to the data lake concept. If you are someone who is new, if you already know those things, please bear with me. And we also touch on the serverless introduction, which is a little bit, and then we'll see some of the common AWS services that we use in the data lake. And I have a cool demo that's an open source project from Amazon itself. I'll just show you how to implement a production grade enterprise data lake in AWS at almost no time. And I also have the code to walk you through, guys. So let's go to the introduction. So the data lake, if you look at this, data lake is nothing but just a kind of centralized a repository to hold all the enterprise-wide data. Say you have data from your social media, Twitter, Facebook, and say you have your mobile application, web application, and so forth. And the organization want to store all those data in a centralized place so that they can use it for various purposes. It could be a simple report for compliance and other reasons, or sometimes it could be for a complex complex reporting for a different purpose, and sometimes even it could be for your machine learning, artificial intelligence, those kind of cool stuff. So I've got this diagram on your right, which I've seen online. I thought it's pretty cool, so I just brought it here so you can picture what the actual data lake does. So like I said, you may have a different data source. The data source could be your database, could be your SaaS-based application, or it could be a simple file comes from somewhere, and you want that data to be stored in a centralized location for a lake purpose. So that storage should have a proper data catalog so that we know what data we have in the repo, and there should be some sort of lineage in place at least. These are all for the governance purpose, so we know the data that we received is the data what we have. And we also have to have a capability to explore the data. So let's say I have a Twitter data and somebody wants to understand what the data is and how many feeds I got in the last 24 hours and so forth. Those are the things they may want to explore on the data lake. So we also have to have an ability to query all those data. That's kind of a foundation of the data lake. And like I said, those data will be used for various purposes. Like I said, for your artificial intelligence workload or your BI reporting, or it could be for a different system you want to transfer this data to. So it's everything related to data. So back in the day, they used to use a different technologies like data warehouse, which I have in the next slide, I believe. But the data lake is evolved from the big data concept. So you're not really restricted to store a certain type of data like your legacy systems and databases. The data lake can hold any format, any type, unlimited, and it's very, very efficient. That's the main purpose of data lake in a nutshell. So before data lake, there was a concept called data warehouse, like you may already know, which is slightly different than what data lake offers. So the data warehouse is all about the data stored in a structured way. It's highly curated in a way that anyone can query. You can easily see the data. You can easily extract in a structured format. And it's mainly used for reporting purpose a lot. And these days, they also use for machine learning purpose. But the data warehouse can generally hold all the structured data in a location, mostly in a database format. So that's what the data warehouse is all about. Whereas on the other hand side, the data lake is completely opposite to the data warehouse. But some sort of, I wouldn't say completely opposite. There are some overlap between these two, but it's more of a non-relational structure. So that means you can store any kind of data in a place where you can query the way how you query in the data warehouse. It's not really curated like in data warehouse. Sometimes the data lake may contain raw format. That means whatever you see, like for example, if it is a JSON format, it will be in the JSON format as well as some other format for you to query. And the data lake is heavily used for advanced analytic purpose, like the machine learning workloads and your all other advanced reporting purposes. But it also uses for your data discovery and to share data between organizations or to a different party. For example, you may have one system in the Salesforce and you want to ingest that into the data lake, and that will be consumed by some other systems like Oracle, for instance. So it also enables the data sharing across different systems. So touch on the serverless now. We all know what is serverless, but just a simple definition: it is an architectural pattern which runs an application without managing any underlying infrastructure by ourselves, but someone else will manage those. That's what the serverless does in a nutshell. And like any other application, one of the reasons we have data lake using serverless technologies is because the cost efficiency, it's very cheap compared to the other technologies. For example, if you had to store a terabyte of data in a SQL server for data warehousing, that would cost you a lot than storing that in an S3. I'm talking in like that will cost in thousands. This will cost you in hundreds. So it's the storage wise, and it's very, very cheap to store petabyte of data in data lake. And the second thing is like scalability. This is the fun part, which I personally love, especially for the data lake, since we have a massive amount of data stored somewhere on the cloud, and someone wants to query, someone wants to build models, someone wants to develop different data solutions using those data. Without the scalability, it's very hard to manage an instance or a server just to accommodate all sort of query. You can build something a bit more at a scaling fashion, but the thing is, still it would cost a lot compared to what you have in serverless. So the serverless is great for scalability. And another top thing is the low maintenance. It's almost no maintenance in the serverless infrastructure. So it's kind of like you don't need someone to manage the infrastructure 24/7, or it's very straightforward. So that's another cool thing that I like in the serverless. So just to touch on the AWS services, like I said, these are some of the services that we use in the normal data lake. So things like the Kinesis and S3, Dynamodb, I'll go one by one. So for example, if you take Kinesis, Kinesis is one of the services from AWS, which is used for streaming purposes heavily. Kinesis comes with different streams, Kinesis Firehose and different services within the Kinesis itself, but the Kinesis Firehose is what the serverless is. So the Kinesis Firehose is a great product because I personally like them, been used a few times. The reason I love Kinesis Firehose is it still enables you to stream the data into the lake. It's a near real time, but the best bit is it's a serverless, so you don't have to manage. Generally speaking, managing a Kafka or even the Kinesis stream is bloody expensive compared to what we get from Firehose. But certain use cases you can achieve through Firehose, but certain things you need a stream. So personally found Kinesis Firehose is a great one. And the S3 is what you will hear everywhere. So S3 is a kind of storage that you may know. It's just a file-based storage. You can just check the stuff in. So it's heavily used in the data world for various purposes. And one of the heavy purposes that we will be doing today is to show you how we put the data in the S3 and how it transforms into different stages. So it's mainly used for your storage, and it's very, very cheap, and they offer 99.11% durability. So it's almost no loss of data, and it's very cheap. And the DynamoDB, recently they have introduced a on-demand DynamoDB, which is great. It's a NoSQL database where we use to store data, sometimes just the metadata. In our case, for the serverless data lake, we won't be storing the actual data in the table itself. So what we do is, excuse me, so we will store all the metadata on the Dynamo tables. We will see it in a minute, and we also have a glue. So here we have a glue on the top, and we also have a Lambda. So you know Lambda much. Paweł also explained Lambda very well. So I'll leave the Lambda part. So the glue is another data processing service. It's mainly used for a batch purpose. Let's say if you are using Lambda, Lambda has its own pros and cons. So one of the cons is it cannot run for hours. So for those cases, we will be using Glue to process all those data. Like I said, some of the data is really huge in volume. So you need some service which runs for a longer time to process and curate all those informations. So it's a combination of both. Sometimes we may use Lambda plus Glue. So it really depends the use case. And the step function is just a workflow which we use to orchestrate our data pipelines. Let's say you have stage 1, 2, 3 jobs you want to orchestrate, you want to trigger one after other. Then we will use step function to build that workflow. And we also have Athena and lake formation. This is another big thing in the AWS world. The Athena is mainly to query the data. So the data that you stored in S3, like I said, one of the the foundational thing of data lake is ability to query your data. So Athena helps you to query the data in a really nice way. So it's charged based on the number of queries you execute, on the volume of data you run. And the lake formation is another huge add-on for your data lake. The lake formation is kind of a security control that you build around the Athena. Say you want to restrict a certain access to a certain team, or you can say only XYZ person should have access to the sensitive information so they can access through Athena. So you can control all those measures using lake formation, which you will see it in the demo. So these are all like a very, very common and simple AWS services that we use on a pretty much day-to-day basis. So without wasting too much of time, so this is the demo I will be showing you. So like I said, this is one of the open source project from Amazon. The reason I chose this project opposed to me creating a simple pipeline is this one is a whole bundle. Like it's a production grade enterprise data lake solution, which you can deploy. You can use it as a reference for your future build, which is pretty cool. I've used the serverless data lake in the past, but this one is actually pretty cool because all the code are in the high standard. It complies with AWS well architect framework. So you can refer to this architecture, refer to the code for your actual development. So the architecture looks a little bit daunting, but it's very simple stuff. What it does is we have an S3 bucket, let's say a kind of a folder or a place where we store the data. And within the S3, we have 3 different zones. As you see it in the bottom, we have a raw, staged, and analytics data. In my code, I actually made it as raw, pre, and post stage, just to simplify stuff. So what it actually does is whatever the file you copy into the raw location, it will then be moved into the pre-processing stage. That means it accepts that file, and then once we have the file in the pre-stage, then we have another job which runs to make it to the post stage. So these 2 jobs is actually a Lambda function. That's what you see. So those 2 Lambda functions are orchestrated using the step function. So the first job is actually does a simple thing. It makes sure that the file what we receive is right, and then it just moves into the pre-stage. And the next Lambda function is what it actually triggers a glue job with those parameters. And so that the glue does the heavy load of process, and then it builds the table definition for you to be able to query. So Athena does require the database and tables to be created in Glue so that Athena can work. So that's what the second step does. So it's all managed in the AWS. It's all serverless. It's got a SQS queue. So whenever we have let's say you copy 10 objects into the S3 bucket, then there will be 10 events that generated through that bucket, and those all goes to the SQS. What SQS does is the Lambda subscribe to the SQS, and the SQS says these are the 3 messages it got, and the Lambda processes it, and it makes sure, like I said, the data, the file is what we expected, and if it is, then it pushes into the other SQS queue. That's where the actual job triggers. So in order to maintain the state, because serverless is a stateless, we will be using Dynamodb just to keep track of what file we received, when it's been triggered, and what was the status of the job, and all those kind of things are stored in the Dynamodb. That's what this whole solution does. So just to get started, these are the 6 steps that we will be performing. I'm not going to really run each step because it takes a little bit longer. Sometimes each step takes 15 to 20 minutes, so it may take over time. So I'm not going to run each step, but I will show you what I exactly do. So it's just that we are not going to trigger a pipeline, the code pipeline, for that to execute and complete. So we're just going to pretend to be that it's executed. So as a first step, the base template, I'll just show you in the code. This is the code of the base template. This is the only manual step that we do. So what it does is it creates a code commit with all the projects or all the code in there. So if you look at the code, what it does is it creates a code commit repository with an IAM attached. So we need a role for our code commit to make an action. So it creates an IAM role, and it builds the code repository with the code from this GitHub link. So this is the only manual step, only the template that you may need, and the rest of the things are all available online. So the rest of the things are in the document itself. So you just need to run this manually, and the rest of the things will be present in your account. So once you run this, once you deploy this template, then it will have all the project code that is required, and it will be available in code commit repository. So as soon as have it in the code commit, then the rest would be just looking at your code commit just to make sure that it's all in there, and then you will just execute one after other. So this is the code commit. These are all the list of repositories it generates.
Fayaz, sorry to
yes,
interrupt.
Rashid. Yes, go ahead.
Yeah, can you please increase the font size of VS Code? It's pretty small for us here on the screen.
Oh, yeah, sure. I will. Let me increase. I'll do it.
Thank you so much.
No worries, thanks. Sorry, guys. Let me quickly. So I'll get into it in a minute. So these are all the code repositories that you will have. So we will start with the foundation as always. The foundation will deploy everything that is required to be able to deploy your code. So what it basically does is, as a second step, if you look back in the slide, the foundation step is what it actually deploys. It deploys the SQS in the what we've seen in the architectural diagram. It deploys the SQS. It deploys the KMS keys, and it also deploys the Dynamo and Lambda and IAM roles and all those kind of things, all the basic stuff that it is required to perform any data movements. Once you have those foundations in there, then the rest would be just triggering one by one. So I will quickly show you the foundation in the VS Code in a second. Just going to. I'm just increasing the font size a little bit, so just bear with me. I will be there in a minute. Yes, I think. Yeah, I hope this is a little bit better, but it still looks. Yeah, I personally prefer to be smaller, so I've had it a bit smaller one. So was there anything improved? I'm not too sure. So this is the foundation one. So this repository, again, I cloned it from the code commit. So what it actually does is it builds the whole stack for you. It also, the best part of this is it also comes with the Kibana, your ELK stack for your monitoring purpose. I haven't applied that in my stack, but you can do so. All you need is you just need to tweak a little bit in the parameter side, and then you should be good to go. So if you look at the template, what it actually does is it creates another IAM role for your DynamoDB and some of the other things to process, like to trigger your glue job, and an IAM role for your Lambda, and so forth. And then we deploy a couple of Lambdas here just to make sure that we make an entry on DynamoDB as soon as we receive the files, and all other things. So once you have the code ready, then there are a list of parameters that you may want to update. So we have currently, it does support 3 environments, dev, prod, test. You can extend that if you want to. So what it does is it takes a couple of parameters. That's a main parameter. This is something usually the admins define at the very initial phase of the project. So we need to define what the organization name is, and what's the application name. So each one could be different. You may have a different application name for your organizations, and you can define a number of bucket. It means the number of bucket you want to create for your different zones. And we also have the SNS notification, which you can enable. So currently it's just I put my email ID. So if you have a team email ID, you can use that. So if there is anything happen, then these admins will get notified. So this email is usually for the admins or DevOps people, whomever it is. So if there is any problem with the infrastructure or the pipeline, they will be the first person to get notified. So similarly, you can change the things for production and test environments. And then once you do that, then all we need is to execute or just merge this change to the kit. And that should be it. So since we already have the code build enabled, and we also have the code pipeline, so this will be triggered in the code pipeline. So once it's triggered the code pipeline, then the rest would be just the implementation. That, like I said, it takes about 20 minutes especially for the foundation one. And once it's get deployed, then you will have the basic stuff in your AWS. So the next step in the implementation is to create a project or a team. So imagine you have the foundation platform, but you want to define which team to use those platform. Say you may have a different teams who want to consume data from your lake. Could be marketing, engineering, or it could be project specific, some specific project you want to create to. So those are the things can be created using the team structure. So within the code commit itself, we have another repository called teams. So I'll quickly show you the teams. Yeah, so if you look at this, what it does is you need to define the team name. Now, you can have multiple teams if you want to. I'm currently have only one team, but it's just the parameters that it takes. So if you have multiple teams, you can just put them up there. So you will create multiple stack for each teams. So the kind of stack it generates is more of the CICD for that specific theme. And the cool part of this solution is it also generates a code repository for those teams, and the CICD code repository and the required IAM role permission for the team and the group. So once you have those created, then all you can do is you just attach each of the IAM user to this IAM role, so they can assume this role and pretend to be an engineering team. So they can just do whatever stuff they wanted to do. So the parameters it takes is fairly straightforward. You just need to define the repository name, and the team name, and we also need to say what's the artifactory, what library they'll be using, and what's the name and the branch. And there is another email address in here. So this email address is slightly different. So this one is specific to that team or project, so that if there is anything happen on the project, they will get notified. Similarly, it's got 3 different environments: dev, prod, and test. And once you change those parameters, then that will get deployed. So this is the actual template. It takes a bunch of parameters. Those parameters comes from the JSON, and then it creates the stack, which is very cool. So you don't have to really work on all those. This is already up there, so it's very easy to use, and you can customize depends on your use case, which is pretty cool. So once you have the team developed, and then the next step would be to so the next step is to define a pipeline. So this pipeline is the actual CI/CD pipeline, or that you want to define, and you will have the step functions and so forth. I'll show it in a minute. So this is the next repository. Again, this is all present in the code commit like any other. And the cool part in here is this pipeline is very specific to the engineering team that we just developed. So if you look at the code commit, and what it will have is it will have the bunch of repositories, and the new repositories that it's added for the engineering team will have the prefix as engineering dash something. So it will have its own pipeline, it will have its own repository, and it will have its own build artifacts. So this is another template. So what it does is, again, it just defines the code pipeline for your project, and it takes the repo name, and then it creates all those artifacts for you. Again, this is all hooked up with the CI/CD. So once you make the change, if you want to change the parameters or do something, you make those changes and commit this change to the Git, and then the code pipeline will be triggered. So if you see, the repo name itself is actually the engineering dash pipeline, because this is specific to the engineering project that we just created in the teams using Teams repo. So if you have a different project, then it will be different name up here. So which is cool. So the thing, what it actually does is there is a common repository within the code commit itself. So what it does is it creates another repository by using the repository which already present in the code commit. That means the boilerplate, which is already available. So every time we generate a new team, that team will have their own repositories from the boilerplate, so they can make customization, they can do whatever they want to do in their repo in the future. So at the initial phase, when we set up our team, this will be available for them. Now, the other thing is the data set. So the data set is slightly different than the actual data set. So what the data set does is it actually helps you to build the actual table definition in Glue. So if you look at the code, what it actually does is it takes a few parameters. It defines which bucket you want to build that table definition from. So like I said, S3 may have different zones, and which zone you want to consume to be able to query from Athena. So like I said, the Glue has to have the table definition. So it crawls those locations, builds the meta store and creates the table for you. So in order to define those things, we need to define the location of that data. And then we also need to define the schema and so forth. So those are the things will be defined in here. And it also controlled by lake formation. So all the templates to build your lake formation and the catalog for those lake formation will all be present in this repository. So once you deploy them, that means your Glue, Athena, and the data lake is actually controlled by the lake formation itself, which is really nice. And then the last step is the actual transformation job. So once you have the code ready with you, and if you want to perform a certain kind of transformation, or if you want to do something a bit more funky, you can do so. So generally speaking, in the data world, for machine learning or any other workload, the data has to be in a certain shape for them to be able to consume. So to make it into that shape, to crunch those large data and do all those kind of stuff is actually performed on the transformation layer. That's kind of a business logic sometimes. So again, there is a code available, the same code repository. I'm using this data lake library code. This is where we actually define the different stages of transformation you want to perform. So in my use case, I'm currently doing stage A and B transformation. The stage A is what it does is just a simple transformation. Stage B just move from one bucket to other, from one location to other. And the stage B is actual heavy load. Even the heavy load is not, there's no heavy logic at the moment, but it actually triggers a glue job with certain parameters so that it builds the table definition for you. So now you can make it different stages here. So you can say stage C, D, E, F, you can orchestrate however you want. And then you need to map those data set against the transformation. So you can say as part of stage A, perform the lightweight. In stage B, you do the heavy transformation, and you can have a stage C, some refresh or remove, whatever. You can have all those kind of mapping in the config itself. So once you have the different level of transformations configured and you have everything mapped, then you can commit this change into the repository that will again trigger the pipeline to be deployed. So in a nutshell, it just brings the end-to-end data pipeline for you. So what it does is it expects a file name or a file in the raw location, and as soon as you have the file name, then it goes to the SQS, and that triggers a Lambda function, which moves the file into the pre-stage. And once we have them in the pre-stage, then again, the glue will pick them up and does the heavy lifting for you. So it moves to the post-stage, and that will be indexed in the glue catalog. So that's pretty much you need for a data lake. So let's see it in the console. So in the console, if you look at them, what we have, the list of repositories that I showed you. So these are the repos which is available in GitHub. I'll just copy it over to code commit. And then this is all connected to the build artifact. So it just runs in the code pipeline. If you look at the code pipeline, those repositories or those teams will have their own pipelines to trigger. So whenever you make changes to those repositories, that change will commence as it happens. So just to show you a quick demo, this is the data lake. Present that this is as a single bucket that I will be using as a lake for this purpose. So what I will be doing is I will be uploading a quick file in here, so you can actually query those files from the lake. So let me deploy that for you just a minute. So all I wanted to show you today is just to see how it queries the data. So imagine we have a huge JSON object with all the data that is required. And what we will be doing is we'll be doing a simple transformation, which converts the JSON to a snappy compressed Parquet file in the post stage. And that will be available for you to query in Athena. So if you look at the screen, what is it? Sorry. So if you look at the screen, what I'm currently doing is I'm just deploying the code, so the copying those files into the S3 rec. So as soon as it copies into the S3 bucket, then the job gets triggered, which we will see in a minute. So in a nutshell, it's purely stateless. That means you don't have to really run a server behind to watch out for this change or watch out for the new files which is arrived. So it's very cool. So it's fairly simple and straightforward, and it's very cheap way of doing stuff. So all I'm doing is I'm just transferring 3 files, but we will be looking at this JSON object that you see on the screen. So this object is a kind of whole big stuff in there. So it's got all the legislator person names with their details, with some links to be loaded. So it's a JSON format. It's all copied into the location that we wanted to. So if I go back to the console, you will see the files are actually copied into the raw bucket. So if I go to the raw zone, you will see those files. So this is for the engineering team, the legislation data set, and it's all copied. Yeah, it's all copied. So this is kind of how we copy the files. So similarly, in the real world scenario, you may have you may have the some kind of SFTP or some streaming like Kinesis, which actually pushes the file into S3. And as soon as you have the file landed in S3, then the events get triggered. So what you see in here is actually the raw, which doesn't do anything. It's the same format as what we've seen in the actual VS Code view. And if you look at the pre-stage, so in the pre-stage, it actually copied those files straight after. So the thing is, you can see it's already copied. So it's in the same JSON format. It's slightly modified in the way that the file names are a bit changed. So the reason we do this step is because we don't want to trigger the actual data pipeline for every file we receive. And we don't want to be processing every single file that we receive in the data lake again. Then it will become a data swamp. So we want the data lake to be clean. So the file that we receive in the lake has to be informed. It has to have a proper tagging in proper schema, so we know what's coming in, the proper file name. So we know this is a file coming in for this purpose, and we can make use of them, and we can store it in a way that it's ready for querying. So I just passed in, so we just moved into the pre-stage. It happens immediately. If you can look at the timestamp, it's just straight after. So what it does is it just copies through the Lambda. So it makes sure that this is the file we expected. Yep. Then it just copies into the pre-stage. So now the post-stage actually takes about 5 minutes to trigger. So I'm not too sure that's been triggered. The post-stage is what it actually uses the glue job to do the actual transformation. So like I said, in the actual Lambda, the Lambda cannot go over 15 minutes. So if you have any job which need to be run for a couple of hours, if it's got a terabytes of data to process, something like that, then you can use Glue to do that. So Glue itself has Python and Spark ability. So you can run your Python code or Spark code using Glue, which is again a sort of serverless. So you don't have to manage anything. You just submit a job and that will be completed. So it takes 5 minutes to pull the change. So yeah, it's done. So now you see the file is actually changed into a Parquet format with a snappy compression. This is a bit more it's a better way of storing the data in the data lake. I personally prefer Parquet over Avro, and the compressed format is always good, especially if you are using Athena to query. So once we have it in here, if you look at the Glue job, so you will see, so this is the Glue console. So if you go to the Glue, you will see a couple of tables created. And if you go to the job, and you will see the engineering job, the legislator Glue job, which has been triggered just now. And it took a minute to complete because we don't have any huge logic. But if you are even running for hours, it should complete. So once it's completed, then you should be able to query from Athena. So I'm just going to go straight into Athena just to show you the data. So those messy data that we've seen in the JSON format is actually translated to a Parquet, and now you should be able to query nicely in Athena. It's all serverless. So if you don't receive any files for a specific day, you pay nothing, which is really great. So now you can see all those links, names, and all the details are up here. So any business analyst, developer, or the data scientist, now they can query this feed and perform a certain basic analysis to make their models or their analysis or report, whatever. So this is what it does in a nutshell. So for me to be able to query, I need to add permission to this table, which I already did. So if you go to the lake formation, this is the lake formation UI, which is cool. What you can do it in here, though, you can restrict access on a database level, column level, or even a table level. So that means not everyone will have access to everything. So you can restrict an access on a role base. Let's say the engineering team would have only access to the engineering tables. You can do that, or the engineering database. You can do that, and within the engineering, you can define certain peoples will have access to every column. Certain people will have a restricted access. You can play around. So all of those security is managed within Lake Formation. So if you want to grant access to someone, you just click on the grant button, and then you just define who's that user. So if it is a IAM user, if it is a specific role you want to give access to, you can choose that account, and then you just define what level of access you want to define and just grant. It's pretty cool. So the level of access that people get in Athena is based on the level we set in the Lake Formation. That's the best part in the Athena and Lake Formation querying. And the last but not least, the Glue metadata storage. So if you look at the Glue stuff, so it has all the metadata that is required. So it stores everything. It stores, this is the data file that I received on the particular, whatever the date is, with the timestamp, and who pushed that file, and what happened to that file, what was the size of that file, and all those kind of metadata will be stored in the DynamoDB. And this is one of the table. Likewise, you have multiple tables. You also have the data quality check in place. There is a tool called DQ. Personally, I've never used it, so I haven't included in this demo. But the project also comes with the DQ data quality check, so you can use that tool to further elaborate on the data quality side of things. And lastly, if you look at the teams, so the teams that we created in the code, which all comes in from here. So if you are creating multiple teams, then all will be recorded in the DynamoDB itself. So you kind of DynamoDB is your meta repository where you can go and see what file I got, who got what access, and when was the last process, whether it's a success or failure, and pretty much everything. So there is another thing within this stack, which I haven't included again. That's a ELK stack, the Elasticsearch stack. So what it actually does is it gives you a nice UI, so a cool visualization. So ELK itself is used for monitoring purpose. So it monitors your lake, and if there is anything changes and what number of files you got, all the things will be visualized in the ELK using Kibana. The code is available within the same repository, so you just need to tweak the parameter to be able to deploy them. So that's what it does. So a few Lambda that it's already deployed. So like I said, they will have every team will have their own Lambda functions to process their data feeds. They can have XYZ stages, which all orchestrated in the state function. That's pretty much I have it on the code. So just to summarize, what we've seen so far is, so we started off with the Cloudformation stack, the base template. The base template is what it actually, the magic template. It just copies all the code from the GitHub and put them into the code commit, and it attaches the IAM role to be able to deploy the rest of the stacks. So once we have the Cloudformation code commit ready, and then we build the pipeline, we have the S3 bucket, which is created so that we can accept files coming into the lake. And we have the DynamoDB to store all the metadata. Within the DynamoDB, we have multiple tables for different purposes. We've seen a couple, and then we also had a data processing layer using Lambda and Glue. Lambda is for a lightweight, and Glue if there is any batch sort of processing. And we queried through Athena, and we also seen the lake formation of how it manages end-to-end. So that's pretty much I have. So yeah, that's all I have for today. So yeah, I'll leave it to the team if you have any questions.
Thank you so much, Fayaz. That was a really interesting session. Personally, I have never built or looked at a data lake, and this was really interesting, and I'm sure our audience also will try it out. So, Fayaz, can you share the link of the open source project that you have selected? I think we have a few requests for the link. That would be helpful.
Yeah, sure. Yeah, definitely. I will post them up in the chat window for you. Yeah, it's a pretty cool project. I personally found them very useful. It's got all the things that are required to build a data lake. And the best part of that, though, it takes hours to develop a lake, which is pretty cool because usually it's a lot of stuff to do. So if you have to develop a lake with all the things that I've showed you, it takes a couple of months. Whereas AWS is being very generous to open source that project, so anyone can use that for the reference, and they can customize it. Depends on the use case they're building. I just shared the link with you.
I've posted it already on the chat, YouTube chat.
Awesome. Thank you.
Thank you. Let me just quickly check if there are any questions. I don't see any questions as such. Okay. So thank you so much, Fayaz, for joining us here today.
Pleasure. Thanks a lot for having me. It's been wonderful with you guys. Thank you.
Yeah, I think we have
one message for question.
It looks like he's typing it out.
Yeah, sure.
So Fayaz, you're from Australia, right?
Yeah, I'm currently in Melbourne. Yeah. So how's your day been, guys? You been good? Hope everyone is safe there.
Yes. I mean, the situation is slowly coming under control. At least that's what we hope for.
Yeah. Hopefully things will get better soon. Yeah.
Okay.
It's wonderful to be here. It's a great initiative, guys. Well done.
Thank you so much. So while Christy Thomas is typing the question, we have a couple of announcements. Ismail, would you like to give them?
Yes. I'll share my screen.
Yes. Okay, I think we have the question. As I'm putting it on the screen.
Yeah. GitHub to code commit. Can we use GitHub as a source stage? Yeah, it's a very good question. So he's asking why we have a template which copies the code from GitHub to code commit. So one of the purpose is to use a pure serverless technologies within AWS Stack, and also for the enterprise data lake, code commit is a bit more secure. Sometimes I feel, and it goes quite easily with the code built and the code pipeline. So it's fairly one stack to manage your end-to-end CI/CD and all your DevOps. So that was the reason I copied over. But if you want to keep it within the GitHub, you can do so. The code is actually in the GitHub itself. So you can keep it in the GitHub and you just set up an access between GitHub and the code pipeline, and that should work the same way as how we're doing it now. There shouldn't be any changes for sure.
Thank you. Thank you, Christy Thomas, for the question as well.
Thanks, Christy, for the question.
Yes, and if anybody else also has any questions, please do post them. And yeah, Smile, you can go ahead.
Yes. My screen is visible, right?
Yes, okay.
Okay, so we have a couple of announcements for the people who have joined late. First is that CFP is open for AWS Community Day for South Asia. It will be closed on 11 September 2021. So if you are interested to speak at AWS Community Day, then feel free to drop your CFPs at the link. We have already added the link in the chat section. Next announcement is regarding AWS certifications. If you're looking to prepare or give AWS exams, you can just check this out. You can request for your free practice exams, and for all the associate level of exams, you can get a 50% discount on the exam voucher code. Again, both of the links for them for practice exam and for discounted voucher code has been dashed in the comment section. The last but not the least, applications for AWS Community Builder program have been opened again, and it is one of the amazing communities out there. So if you are looking forward to interact with a lot of AWS community, AWS aspirants, and AWS experts, you do apply for this program. Application for this program closes on this August 30th. Last but not the least, if you are looking forward for a single page resource where you can find all the details about Serverless Saturdays, all the past episodes of Serverless Saturdays, who is the speaker, how to connect with them, and the slides for every presentation you can find in this repo, that is Serverless Saturdays. We'll share the link for this repo in the chat section. And yes, last but not the least, if you're interested in presenting for Serverless Saturdays, or if you're looking for any specific events that or any specific topics to be touched, please feel free to reach out at the mentioned email IDs, and we all will be happy to answer.
So much, Smile, for that. And Fayaz, there's a request from Christy Thomas to have you back for managed airflow and data pipeline. And I hope we have you back sometime in the future for the requested session. Fayaz, if you're speaking, you're on mute again.
Sorry, again, I was on mute. Sorry. Yeah, thanks a lot. Oh, we definitely would love to. Would love to come back sometime in the future with those topics, which is great. Thank you.
Thank you. Thank you so much, Fayaz, for joining us all the way from Australia.
No, my pleasure. Thanks a lot.
It was an amazing session, and I'm sure our audience would have loved it. Thank you so much.
Thanks a lot. Take care, guys. Thank you again. Bye.
So that was Serverless Saturdays for the 6th edition. And we also have a couple of sessions lined up already for the next month. We will be announcing the details of the 7th edition soon. So please stay tuned for that. And again, 2 interesting topics are lined up. And as Smile has already mentioned, if you guys are interested in presenting or looking forward for any specific requests, like what we have just got from Christy, please do reach out to us. We will try to find more speakers, and we'll get those sessions on Serverless Saturdays. Thank you so much for joining us today, and stay safe and have a happy weekend. Bye-bye.